Hey, it's been a while, to say the least. I gotta mute this. Hold on. Good old forgetting to mute the background stuff. Let me see what's going on. This is streaming 101 right here, right? It's let's see where it's kicking up. Ooh. There we go. Perfect. Okay. So, like I said, it's been a while. Thanks for jumping on. Idea here was I fired up a tweet storm the other day around picking a container service. And that really blew up. And it was interesting because I was trying to work through my process. I put on sort of a new user hat and tried to figure out what was the best way to launch a single container. Got a lot of great feedback around that thought process, how to launch a container in AWS, things like that. And I thought, great way to get back on the streaming horse is to walk through real quick, so 30 minutes or less, walk through a thought process on how to pick a backend for a serverless project that I'm firing up. Now, the reason why I'm picking serverless is because this is a side project that I'm looking to get my basically research on a bunch of stuff where I'm looking to pull together information from the community and make it easier for myself to digest and obviously share it out with you. And I want this serverless because I don't want to be doing a lot of it. If I don't want to be paying attention to it, I want it just automatically showing up with the data. I don't want to have any really operational requirements beyond just some sanity checks and some safety measures to make sure what's going on. And if you're wondering why my eyes are darting around, I'm just making sure everything's running well and then my audio isn't spiking too much. Things like that, I think we're doing good. Let me know in the comments. I'm monitoring those as we go through. But like I said, I'm trying to figure this out as far as the serverless project. What do I want to do, for a database backend? That's my first choice. That's what we're going to talk about today. Let me kick over to the display and we'll take a look at what I've got in mind here. So, this is my site, and let me show you what kicked all this off. Was this thread that I went 44 tweets, kind of crazy. You can catch this up, markn.ca, and you can see I was going just literally through the process of saying, how do I start? What is the basics, and how do I move forward in AWS? And I go through and I took screenshots, and everybody really appreciated this thought process. So we're going to do the same thing, but this time we're doing it with this serverless backend. So let me pull up my image here for you. Okay, here we go. So what I have is basically a bunch of objects, things that I'm tracking, and I'll tell you in the next few streams, the next few videos, exactly what I'm building. But for right now, you can just think of, I have an object, and that object has a bunch of children that are associated to it. So there's something, and it has other things associated to it, and each of those so the child level has updates that happen on a regular basis. And what I want to actually do is not only map out that object level, but I want to then track the new. So I want to see the changes over time so that I have a historical record as these things have changed over time, but I also want to be able to cross-reference them. Now, it's really important when you're picking a data store to figure out what you're actually trying to store to start with. Otherwise, you may go down the wrong path. Now, the challenge I've found personally is that specifically with a data store is that you could pretty much shove any kind of data into any kind of store. The challenge is what trade-offs are you making? Do you know what those trade-offs are? Does it make any sense? And that's really where you get into trouble, is that you don't know until you find out, until you hit a roadblock, that you've made a mistake. You've picked the wrong type of data storage. So if we're looking at this, we could be using something like Amazon TimeStream, which is literally time series data that works through. But, because that's going to get the news stuff, but that's not going to let me pull those objects at the right level that I want to. So again, we're looking for a serverless data store. We have parent objects, then child objects. Those don't change that frequently, but then we have frequent news associated to each of the children. Now the read that we're looking for, that's the write, that's how we want to, that's what we're tracking. How are we reading this? Well, we want to be able to output, not in real time, we're writing batches. So I'm just basically sending myself myself an email or creating a document that I can review or share with these updates and how things have changed over time. So we're going to be slicing and dicing this a bunch of different ways, but time isn't a big factor. We don't need real-time queries back here. We don't have to worry about caching stuff. If a query takes 2 or 3 minutes, that's okay, because essentially this is getting reviewed once a day. So that's our scenario. This is what we're storing. This is the structure we're looking to store, or at least the mental structure I've got of what we're looking to store. I'm flexible on how we actually put it in there, but we don't have a lot of read constraints because we're only reading kind of once a day. So we can do some heavy lifting there. It's probably going to be best to write. We're doing maybe 3 to 4 writes per day, or at least complete sweeps of the space that we're looking at. So we'll be writing far more often than we're reading. So that's something to keep in mind. And I want serverless again because I very much don't want to run anything. I want to keep the cost low, and I want to not run anything if I don't have to. Excuse me. So let me just double check, see what's going on the stream, make sure everything is running okay. We're doing good here. It looks like the stream is healthy. So let's dive into this. We've got our general thing. Now, right out of the gate, I would say, based on experience, DynamoDB is a great choice. DynamoDB is fantastic. It is very much serverless. We're going to look at it specifically. Most of the time, you're going to need help. So Alex DeBrie's book, the DynamoDB book, is the place to be. Fantastic, helps you understand it, but we're not going to jump to conclusions yet. I just wanted to bring that up before I forgot, because I think it's really, really important. So we're going to start actually with a Google search. We are going to search for, we're going to start with Google Cloud. Oh, let me get in the right box here. Google Cloud. That's a little serverless database. Let's see what comes up. So right off the bat, if we ignore the ads, which is always frustrating, we've got Google Cloud databases and then Google serverless computing solutions. Let's see what's here for serverless computing solutions. Do they actually mean compute? And it looks like they may actually mean compute. Let's scroll down. And again, this is similar to what I was doing with the container thread, is from a new user perspective. I'm taking off sort of my existing knowledge hat. This is just an ad for serverless design and actually doesn't get me where I want to go. So I'm going to close that tab and I'm going to actually go to Google Cloud databases. Let's see if this will give us what I want. So here we've got Google Cloud databases take on the unpredictable with groundbreaking technologies. Oh my God. Okay. Ignore the marketing hype. Let's go down and see if we can actually start to look. Yes, okay, so this is solid. This is a good table. It gives us a database type on the left, and then the cloud service with the specific, use cases. So this is really a good approach. A relational database, so tables, columns, and rows. I get a bare metal solution for Oracle or Cloud SQL, which is managed MySQL or Postgres or SQL Server. That's a traditional database. That will get the job done. However, I have a feeling that's probably going to be too big. I don't want to run instances or servers in the background. Cloud Spanner, cloud native with unlimited scale. Again, that's relational. Let's keep going down. We've got a key value store. So you literally have a key and it looks up a value for Bigtable. That's a possibility, okay? Their recommended use cases though, personalization, ad tech, recommendation engine. So this may be overkill based on their description, but that's still, it's a potential. And then we've got document, we've got Firestore, cloud native, NoSQL, easy to develop, rich mobile, web, and IoT applications. So real-time sync, offline sync. Might fit. We're going to come back and circle out. Let's keep going down and look. We don't want Firebase real time. We don't need real time. MongoDB Atlas is interesting. So that's a document, additional NoSQL from a third party. So let's just go into Firestore for a second here. Let's dive in and let's see what's up with Firestore. Serverless document database. Perfect, right? First thing, that's exactly what I want. Great. Accelerate mobile. I don't care about mobile. I don't care about the synchronization. So as long as I'm not forced to synchronize stuff, this might be where I want to go. But one of the biggest tricks I use when I'm evaluating a service is actually looking at the pricing page. And the reason being is because if you know what you're paying for, very, very quickly, it'll tell you if it's actually serverless and sort of the operational metrics on which you're going to be really having to pay attention. So if we scroll down, and literally that is a scroll down, this is really promising. So we're being billed on stored data, makes sense. That's going to be pretty much true for all databases. Bandwidth, that's true of all cloud services. Document reads and writes and deletes. So there's no instances, there's no clusters, there's nothing like that. So Firestore is a potential. Now the cost is pretty cheap. We will rarely get to a gig in this project. So 18 cents a month is not that bad. 100,000 writes for 18 cents, 100,000 reads. So, I mean, we are not going to be paying more than $1 a month for this one. So we've got Firestore here. This is a good option. Let's click back to the tab and let's look at MongoDB Atlas, which is actually kicking us out to MongoDB because there's a partnership in place with Mongo where they're actually showing you those services through there. Now the challenge here is there's not much. So highly scalable, great. Automated database operations, okay. Global clusters, sure, I really don't want that. But what I want to know is how you bill me. So if I keep going down here, deploy a free cluster right now. That does not sound promising. This is really not a great web page. Let's click this out and let's go back to the main Mongo and see what the options are here. So for products, Atlas, Enterprise Advanced, Community Edition, Realm. What I want is their cloud, their hosted one. I don't want to host anything. So I think that's Atlas itself, but this is now through the main one. Let's look at the pricing for cloud, Atlas. Ooh, serverless. There we go. So from 30 cents for a million reads up to a terabyte of storage. Let's expand this out. Okay, serverless database, pay for only the operations you run. That's exactly the use case we are looking for, is just paying for what we run. Reading is 30 cents for the first 5 million per day. So super cheap. Write processing is 125 per million. So writing is more expensive here. Data storage is a little bit more than what we were looking at, and they have a backup option. But what's concerning me here is that writing is more expensive than reading. And we talked about our use case in the start, where we are going to be writing far more often than we're reading. Now that being said, $1.25 per million, I don't think we're going to get up to that. So we're still under a couple bucks per month, but it seems like Firestore may be the best bet when it comes to Google Cloud. Okay, Google Cloud out of the way, let's go for Azure. So let's type Azure Serverless Database. Let's see that. So we've got two good options with, yes, I know, snitch. We've got two great options when it comes to Google Cloud, or at least one in Google Cloud, one adjacent to Google Cloud. Here is a great, that's not from Azure though, but like, what should we use for a serverless app? But let's go look to the serverless compute tier here. This is SQL database serverless. It's a compute tier for single databases in an SQL that automatically scales the compute based on, no, not what I want. Anytime they talk about you scaling compute, that is not at all going to be what you were looking for. So let's go back to the main Azure page, because that Google search was kind of a bust. At least for the first couple. Now, this is one of the frustrating things I find for most of this time, most of the use cases, is that when you're looking at these solutions, your first stop is always a Google search. And if the service provider hasn't invested in getting that SEO in place to make sure that you're landing on the right metric, like when we got on that Google page with the table, that's really useful in that figuring out what the right solution is. Here, let's go to the services for database. Let's see the one-liners. Hopefully something's going to jump out at us. Azure SQL, modern SQL for migration and app modernization. Okay. Cosmos, fast NoSQL database with open APIs. Okay, that's kind of promising. SQL database, Azure database for Postgres, managed instance, database for MySQL, SQL Server. Okay, so there's nothing that's jumping out at me here that is serverless. There's no serverless option on here. Let's try Cosmos because it's a NoSQL database, which may give us the chance not to worry about this. So fully managed NoSQL database for modern app development. That sounds great. Single digit millisecond response times. Nice. Good uptime. Again, this is the way to cut through all the marketing crap. Click on pricing, see what you're getting billed for. So it's a 2-clicker, and here we go as far as This is an odd combo. Central US, billed in Australian dollars. Let's go Canadian dollars because that's where I am. So serverless, hey, here we go. First mention of serverless, and only because I guessed on a server to use. Not phenomenal, we could look better, could have a better look here. Database operations, serverless, build for the request units for each database operation. Makes it easy to run spiky workloads that don't have sustained traffic. Can handle bursts without resource planning or management. Perfect. Consumed storage, so build is consumed, sure, how much I'm storing. And then the dedicated gateway, which I don't want and don't want to deal with. So let's look at the serverless pricing here. Low traffic, great, that's exactly what we are. We are a comparatively low traffic project here. Intermittent bursts on demand, okay. Serverless request units, sure, I hate when they make up their own thing, but it makes sense in the abstract, but it just takes more time. 1 million units for 36 cents, that's not bad. 1 million request units within the with availability zone for some reason is a different calculation. That doesn't make any sense to me, but we're in the range here. For 1 million operations, we are sitting there at 36 cents. For consumed storage, for transactional storage, is 32 cents a month for a gig. So again, this is going to cost us, maybe under $1. Very, very similar to Firestore. So we've got two good options here. Let's get rid of the tab for Mongo. So we've got Cosmos DB and we've got Firestore. Now there wasn't anything else on Azure that jumped out at me that was potential, but let's just double check again. Azure serverless data. So I can click through the top ones and add from them. Now, this is to the functions. Now, serverless functions are great. No, I don't want to do a survey. I'm streaming. Don't want to deal with that. Let me just double check. Everything's looking good over there. Okay. So one of the ways you can also find for serverless is go through compute. Now, the reason why I didn't start with compute and didn't say, hey, I want to build this in Azure or in Google Cloud or AWS was because the functions that enter all three can do what we want to do. That's not going to be a problem to go out and process stuff and put right into the database. The database was really the biggest difference. Now, what I'm looking for as I scroll down this Azure function, so the compute side, is any indication of like, hey, you should be using this kind of a data store with it. Now, there really isn't anything here other than maybe the cookbook, step-by-step guide. Yeah, let's click into that for a second. Now, this is way more work than it should be. 100% honest, and of course I have to log in to do the cookbook. Not cool, man. I just want to see if you've got options. Okay, let's jump off Azure. We've got one option on Azure. We've got Cosmos DB, and then we're go to AWS. So let's go AWS serverless database. Ooh, serverless database options. AWS data services, best blah, 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 blah. Here we go. Amazon blog. Understanding database options for your serverless web applications. Okay, great. Access RDS with Lambda functions. Okay, RDS is the relational database service. You can see here it explains how you can do that. Aurora, using DynamoDB as a high performance operational database. Okay, so Dynamo is a possibility. Combining Dynamo with RDS. I don't want to add, like I'm not that complicated. This is really simple. So that's it. They just say that there's two things. You can go RDS or you can go Dynamo. Okay, I already mentioned Dynamo in the intro. Let's look at RDS and see if there are options there. So if we click on database, RDS is not, oh, there it is. RDS is listed here. Anything else jumping out in the service? Nope. Lots of different database options, but nothing screaming serverless to me. So we know from this blog post that RDS is a possibility. Let's jump right into pricing, cut through all the BS, and look at what we're getting here. So it tells us about the free tier, that's fine. All of these options, wow. Okay, this is a lot. MySQL, Postgres, Oracle, SQL Server, MariaDB. Okay, it had mentioned Aurora. Let's see that. So database instances, not what I want. Database storage, no, I don't want instances. That means we're running something or something is always running. So there's nothing on serverless in here. I could have sworn that it said serverless on there. Let's do an in-page search. Server, yeah, okay. Aurora serverless. Okay, so this is on a different Oh, and it's in preview. V2 is in preview. Okay. But there is a V1. All right, what's the V2 preview? Highly scalable. Yes, great, durable, simple. Removes the complexity of provision and managing database capacity. That's what we're looking for. We don't want complexity. Complexity sucks. Christopher, I see you're saying Dynamo. That's what we're going to double check next here. We're taking that approach of, hey, you know, what can we find by Googling without knowing a whole bunch of stuff under the covers? It looks like Aurora serverless is an option. Where is the pricing for it is my question. Because we clicked on pricing and database instances, blah, 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 blah. Additional pricing resource. Like there's no list of pricing on the pricing page. You would think that you would add pricing on the pricing page. Let's AWS Aurora serverless. There we go, pricing. It's a common question apparently. Is serverless cheaper? Here we go. Let's see this. Okay. Why? Again, I'm on a third-party site. I don't like that. I want to try to stay as native as possible. It literally isn't going to tell me the pricing, is it? Okay. Well, that's a fail. If I can't quickly and easily figure out the pricing to figure out what is going on, then that is not going to be a good option for us. What if I click on V1 and give them that benefit? Nope. Okay. Wow. So I have to click through to something else to figure out the pricing. That is not at all okay. This should be crystal clear, especially when there's a freaking pricing link right there. But if I click on this one, is this going to tell me? Yep, nothing. Nothing other than serverless configuration, and that's going to click us right back to the same page. So I can't find out easily how much this is going to cost me, which means it's not a good fit for my project. So I will go back and we will circle back to DynamoDB, which we know is fast and flexible, NoSQL database for any scale. Now I've used this quite a bit, but you know, this did come up in our search. So we know right here, application, number one use case, serverless web apps, right? Great. Let's click on pricing and figure out what we're actually billing for. So on-demand capacity or provision capacity, that makes sense. If I know what my workflow looks like, I can actually lock this in and say, okay, I'm gonna pay less because I'm gonna provision capacity. At least I assume that's what it is. But I'm gonna price for on-demand capacity. So it defines what these terms are. Again, we're paying for reads, we're paying for writes, replications. There's a streaming option. Okay, so there's a lot of different stuff. Are you gonna give me a price? This is what I would love to see, is an actual price. Is it hidden here? Hey, there we go. Okay, this is too hard. This should not be this hard to tell me how much things are going to charge, but this is lining up with what we want. Write requests are $1.25 per million. Read is 25 cents per million. So again, this costs more to write than to read. In our use case is the flip, which admittedly is the opposite of most database use cases. Most of the time you're reading way more than you're writing. And then first 25 gig is free. So that's great. That means that our project is essentially going to be free for storage, because there's no way we're going to crush above 25 gig, which means, you know, we're probably under $2, under, you know, somewhere in there, depending on how they build these million writes. Are they billing me just for a million, or is it fractional cost based on that? And then if I want to go something like global tables, so this is for a more robust version, which we probably don't actually need. So it seems like this is a pretty reasonable amount, and there is a good chance that I'll be in the free tier for a little while. Yes, Christopher, 100% on, we've all seen Corey Quinn's rants on pricing. Christopher is in the comments there. He's saying, when you want to be surprised by the invoice. That is 100% true. Because again, the pricing calculator, if you, just to take a sidetrack, if you go into the pricing calculator, you literally have to pick out services that you want. So maybe we can actually find Aurora serverless in here. Maybe? Let's see. Serverless. Oh, look. It only took going to a completely different functionality within the web page to figure out what we needed to do. Now, we don't have per hour. We're having, let's go per month. So let's say we did 1 million writes or 1 million capacity units per month. What is that going to actually be? That is not at all what we want to be. We don't want those capacity units. I obviously don't know what the heck a capacity unit is, because I'm not going to spend $60,000 on a thing. So 786, yeah. So minimum cost for a capacity unit is $46 US a month. Now, I don't know what a capacity unit is. I'll be 100% honest with you. Let's Google that real quick, because right now Dynamo looks like it's our best shot. Aurora, AWS Aurora serverless capacity unit. What is a capacity unit, and do I care about it? Aurora V1, they are doing V2 preview as we saw, but V1, so Provision DB Engine is designed for predictable workloads. When you work on provision clusters, you choose the DB instance class. Yeah, we're not doing that. Serverless DB Engine is designed for different usage patterns entirely. Okay, great, blah, blah, blah. For a case that configuring capacity correctly in advance isn't always possible. By using this, you can make an endpoint without classifying the size, good, the minimum and maximum range for the cluster's capacity. The V1 database makes up the router. Dear Lord, that's complex. So basically what it's saying is we just say we want an endpoint and it's going to go up and down. However, how do we price that? So is that we just ignore this and then we come down to storage? Like this does not seem reasonable. Like I got to be missing something here, but we're in. So we go back to Postgres, okay, serverless settings, good. If I go to 1 per hour, are they saying that even if I do a minimum, my minimum cost is $44 an hour or a month? That's nuts. And even if I do, let's say we're conservative at 10 gig, and we're doing, say 10 reads, 10 writes, just roughly 11. So even at that, even if we weren't paying for the capacity, 1150 something, yeah, forget that. That is not at all in the range. Now, fair enough, there's probably something that this makes perfect sense for, but we want to get back into our Dynamo. So if we are right here in the pricing calculator, let's actually pull up Dynamo just to make sure, because as Christopher rightly pointed out, AWS is phenomenal at sort of surprising you as what's going on. So we're going to just select on demand because we don't know what we're doing ahead of time. We want on demand data storage. Let's say we're doing one average item size is probably 10 kilobytes. We're not doing big stuff in here. So we're paying 25 cents a month in storage. Standard writes, transactions, we're not doing transactions. We're only doing, let's say 100,000 writes per, is that 100,000? Yeah, let's say 100,000 writes per, oh, that's not, yeah, million. No, I did too many. That is too many. 1 million. So that's a lot. Let's go per month. We're doing 100,000. There we go. It's going to cost us 13 cents. That makes more sense. And then per month, let's say we're doing 100,000. Even though we have that lopsided workload, let's say we're doing 100,000. That is also going to cost us 4 cents. So we're sitting at 42 cents. So we've gone from $45 to 42 cents. So Dynamo definitely seems like an option. Cosmos DB seems like a good option. And then Firestore seems like a solid option because it's serverless. If we look at that pricing again to confirm, we're looking at, sub $1. Cosmos was looking at sub $1, and then Dynamo sub $1. That is pretty straightforward. Let me flip this back. That's really what I go through for a thought process. So right now what I've worked out is I've got 3 potential solutions to what I want to do. I've got Cosmos DB on Azure, I've got Firestore on Google Cloud, or I've got DynamoDB on AWS. All of them are going to cost me, from the looks of it, from just a ballpark, kind of point of view, I'm looking at potentially $3 to sub $3, $2, probably around there, as long as I don't get hit with any surprises for this little side project. I think that's pretty reasonable. And that's really what I'm trying to accomplish is, I want a low cost, low effort thing. So I'm starting with the most complicated service, which is the data store, right? How am I storing the data? How am I pulling it out of there in order to do all the other stuff? My next thing is going to be picking one of those and then finding the matching compute, because there's no way I'm going to use like AWS Lambda for compute and Cosmos DB and Azure for the backend. Just doesn't make sense for a project like this. I'm going to put it all into one cloud. So once I select the data store, that is going to dictate what function I'm going to use. The good news, they all run Python, they all run Go. I'll probably do this one in Python. And that is going to be the foundation for this research project. Again, I'm pulling in all this information for the community. I'm tracking these changes over time and then putting out reports for myself to consume and then share with you folks. That's really it. So that was my thought process of walking through it. I'm going to cut this stream up a little bit into some sizable chunks. I was really just trying to get back in the habit of engaging, back in the habit of streaming, dealing with the technical glitches and all that kind of stuff. So Lord knows what this looks like on the output. Obviously, it actually got out there, I hope, because I had a good chat with Christopher. But other than that, we'll see. Again, this stuff is fun. I love doing the streaming. I love engaging. And I love working through these solutions like this and showing you my thought process, because I think it's important. And even though we're doing a tiny project, the same thing works for a massive, massive project. You pick the most complicated service that you need to make a choice on first, figure out what that is, how that's going to work for you, and then build out from there, right? So if compute was your most complicated, figure out how you're going to do that first. In our case, for this project, data store was the most complicated. So that's what we figured out first. We have those three viable options: Firestore on Google, Cosmos DB on Azure, DynamoDB on AWS. Now I can just dive in and look at the docs, see how they interact from a programmatic perspective. How do I store data? How do I pull data out? And the biggest defining factor is probably going to be querying. How do I query that structure of data out in a way that I want? Whatever makes that easiest for me is going to be my choice, because they all are in my price range. They're all a couple bucks a month at most. So I'll let you know how that goes. I'll probably write this up as a blog post. Hit me up. markn.ca is the website, and you can see it there as I go through this. Hope this was valuable. Let me know. Hit me up in the comments. Hit me up on social at marknca. Love to chat with you more about this, and let me know what you want to see, or if you want to keep seeing these streams and what you want to see me tackle next. We'll talk to you in the next one.